Hi everyone, thank you for joining me in this episode 11 of the 15 Days of SQL learning series, where each day we take this 30-minute live session to revise the topics which we have listed down as a part of the curriculum for 15 days of SQL. So I'm so glad to have you all here, and half of the work is just showing up, so congratulations for doing that. Hi Mino, nice to have you back. I have a lot of recurrent users and I really like that. Thank you guys for showing up again and tolerating me for all this while. Let's get started with SQL. Today we have window functions. So if you have been part of any SQL community, you would have gotten an idea by now that SQL is definitely the Voldemort of the SQL ecosystem because people don't want to take its name. Everyone is so afraid of using window functions because they have a lot of intricacies and things to ponder over, which may not settle right in with what we have been learning till now, and that's why they are a little feared about. But they're very useful, and especially if you're looking for entry-level roles, breaking into tech, looking for an entry-level data analyst or data engineer position. These SQL questions would be the ones you'd be facing as a part of your interview or a tech screening round. And those, out of 5 SQL questions, if you would have been given, 3 would definitely be involving some sort of window functions. You cannot run from them. So might as well invest your time in this 30 minutes to try and master them, right? So let's start with what are actually window functions. So window functions are very similar to aggregate functions in the sense that they also work with a bunch of rows, like multiple rows. They're not just working on single row, performing some arithmetic operation, some conditional operation on a single row at a time. But whenever they are performing some operation, it is always considering more than one row. Okay. And this sort of procedural activities we have seen before when we were dealing with aggregate functions, right? Now, aggregate functions, the difference here is that aggregate functions dealt with aggregations. That is, they always had a group by clause associated with them. If you have not checked that out, you can check the episode 5 of this playlist. It's on my channel under 15 Days of SQL. And you'd find that these aggregate functions, be it sum, minimum, maximum, average, all of these always had some sort of group by attached to it. Because what we were trying to achieve there was that you take the rows and group them according to some value present in a column, group them into certain groups, and then perform the function on them. So take the sum of their values, take the average of their values, or find the minimum, find the maximum, count them. All of those functions were performed for groups. Whereas here in window functions, even though we are working with multiple rows together, they don't have to be grouped together. Okay, so the rows maintain their individual identity. They are still row and the operation is happening for each row. However, even though it is happening for each row, it is happening over a set of rows. Okay, how we will see as we progress down. So as the name suggests, window functions, right? So even though they are working for that particular row, they take into consideration a frame of rows or the window. Let's look at one example. Any window functions would have this over clause attached to it. This keyword, what it says is that you perform whatever function you want to on the basis of this. Okay, and so everything would be considered before that particular row. Now over what is what this specifies. What here they're trying to find is that the sum of the duration seconds, whatever duration seconds have been recorded, they are trying to calculate the sum over. Okay, so over declares what is the window going to be like. The window here was that you order by the start time. Okay, So what it will do is it will order by the start time, and everything that all of the start time entries which have occurred before this particular row, which is in consideration right now, for which this operation is occurring, for all the rows before it, and this included, this row included, and all of the rows before it, ordered by the start time, the sum would be calculated. Okay, so that is the running total. Correct? That we are getting the sum of everything including this row and everything before this row. This is what the running total definition is, right? It changes with every data entry, that all of the previous entries are added to the current entry, and it keeps on changing. It keeps on the value keeps running ahead as the data points are added. How this was defined as a window function is, we performed our operation, that is we wanted to get the sum of duration which is in seconds. And how did we get it? So we got it by trying to order the start time, because obviously if we wouldn't want it to be in a haphazard fashion. If the duration is occurring, it should occur from the time that it has started, the earliest time which the bike journey started, and then whatever duration has been occurred or whatever was counted after that in the chronological order, because that's what makes sense, right? In the chronological order of the starting of the vehicle is how you would add whatever you want to, if you want the running total of all of the duration performed by the vehicle. For that particular duration, when it went down, what was the running total? That is the sum of durations in seconds before it, and this duration is what we get as a part of this whole query. Let's try to implement it first, and then we'll come to any conclusions. I would post the link to this tutorial. We would not be dealing with the entire tutorial together because it'll be a lot to digest. Hi Kasali, correct me if I'm not pronouncing your name right. The link to the tutorial has been posted, and I would recommend you open the environment in your working station and then perform whatever I am doing side by side. Yeah. Now let's first run the query, and oops, this is not the query, this is the link. Let's just see what this query is actually doing. So okay, let's also add the column which is actually coming into play while performing the window function and creating the window, and then we'll be able to get a clearer picture of what the window function actually did. Now here you see, this is the earliest start time, which is 1st January 2012, and it started at 4 minutes. The duration in seconds were 475. So the running total, nothing occurred before it, so the running total was 475. Next duration in seconds was 162. However, this was the entry of 1st January at 10 minutes. Till that 10 minutes, 3 observations were recorded. This, and this. So all of them were added together, and that was the running total. See, for this start time, this was the running total. What did it include? Everything that occurred for that start time before that start time, including that start time, whatever duration seconds value was before that start time value, for all of the values before it, and for that included is what it included in the running total. Now you see, next is 15 minutes. So 15 minutes, what would it include? Everything above it, right? So everything above it is 475, 162, 145, 1145, and then it will add its corresponding value. So these four values would get added together to give you this new running total. And here in 15 minutes we have two values for the same time. So it will add all 5 of these and the running total would be 3738. Next is for 17 minutes when the value was recorded. What it will do is it will order by start time as we are doing. So starting from the first start time, it started everything before this was recorded, that is these 5 values, they were added together and they were added with its correct corresponding value, and you got a resultant of 4096. So if you have a calculator nearby, you can check the calculation and it would, I am pretty sure, give you the exact result which it is calculating. Why this happens is that SQL considers when you say order by start time is ordered in an ascending fashion. So how the window is calculated is everything occurring before it and including it, the duration of seconds, since we are calculating the sum of duration of seconds, is considered in that particular window and its sum is calculated. Cool. So as it keeps on increasing, everything that happens before it is included. So you see now it is operating on multiple rows. However, when it is taking into consideration which it should be operating on, it is corresponding to a single row, and then with its virtue it is calculating, okay, whatever is before it, I have to consider that also and my corresponding row. So for my corresponding row, this is what the running total would be. So the operation is happening on multiple rows, but it is happening for a single row, as opposed to aggregation functions when you did not have a value per row, you had value per group, right, per category which was present in your grouping column. This is the difference. Now we'd be looking at what all window functions are available, and we'll be focusing on just one for today. The rest we'd be looking at in the next iterations of this series. The basic syntax of this window function is you say some function which should be performed, then you specify over, and then you tell it how the window should be framed. So you can order something that it should take everything here and before this in the order. You can also perform and divide it into groups for generating the window. So within window, then it will do the same thing. Within that group, it will order it and take things according to that order. So for grouping within a window function, you use partition by. Here what they are doing is when you say start terminal duration seconds sum, instead of just considering every entry that occurred before our start time, order by start time, and every entry that occurred before it, we only consider the entries which are part of our group. So we are partitioning by, when we are partitioning by the start terminal, partition by, I hope the spelling is correct. Now what it does is, it takes into consideration, it first divides it into certain groups of whatever the values present in start terminal are. Then for those rows, again it will create the window depending on the order of start time, that everything before the start time would be included for the total and within and then added with the current value. Now you'll see what the difference is. I would have to include this as well. Now you see how the total might have changed. So now you see when the start time here it says 1532, that is when it has just begun for this 3100 start terminal. It was 74. Now 1240. So everything here and above is considered, and we have a running total. Then for the next corresponding rows, everything here and above is considered for the total till whenever these values for 3100 are. Then it will consider the next start terminal and calculate our running total on the basis of that start terminal itself, and not mix it up with the values of this start terminal. So what we basically did was we performed a partition based on that start terminal, and now within that start terminal we have again created our window that I want everything here and above it according to the start time, however the start time ranks it, and this should give me the total, the running total. Okay, I hope this was clear. If there's something which is bothering you, feel free to put it on the chat. Next, let's go over our actual window functions, which we would be dealing with today. Let's first try a practice problem. What is the practice problem? Write a query modification of the above example query that shows the duration of each ride as a percentage of total time accrued by riders from each start terminal. Okay, so till now we had a running total, but it does not want the running total, it wants the percentage. Now what this gave was, they have written certain query which they want us to modify. Okay, this is the query. First let's learn what this query is actually doing, and then we'll take a look at So it generated this result that for every start terminal it has the duration and then it has the overall total. Okay, it is not running total, but it is just partitioning it or grouping it on the basis of start terminal, and then no other window is introduced, that is that you should have it by start time, that only this much start time should be considered. No, it just performed the partition on the basis of start terminal. This same thing can also be achieved by a simple aggregate function with a group by clause. Now what they are trying to do here is, but the next part of the query won't be able to. So if we did this start terminal getting the total for the start terminal, the entire total of all of the seconds, this was achievable with a simple sum group by. However, now what they want is, they don't just want the sum, they want what percentage was that particular row's duration seconds out of the total time. Now here you see how your operation is for your row, for a single row. For each of the rows you have to perform the operation. However, the operation might be getting performed on multiple rows, but it is for this row, but it also takes into consideration all of the rest of the rows for that terminal, so to calculate this total. And now we'll just be getting a percentage of what it is. So we'll say instead of just sum, we'll say duration seconds divided by sum, which will give us the fraction of what part it is. And then to convert it into percentage, I'll just divide it to 100 to avoid integer decimal fraction. To avoid integer division, I will add 100.0, and I won't have total, I'll say percentage. Okay, so now you see the row in consideration was the current row. I got unique percentages for each row. However, they did consider all of the rows for that particular start terminal to calculate the total. Once the total was calculated, they performed the sum on all of the duration seconds, the total was calculated, and then it was used for this percentage calculation for that particular row. That's how window functions work. Let's compare it with the answer which they have and see if they did. Oh, so they had the start terminal sum and they created another, this whole thing itself where they are performing this division and they're getting it. This is what we did, right? We did duration by sum of duration seconds, multiplied it by 100. They have done it in a separate statement. We just edited the statement that they give and got the same answer as they did. Cool. Now we're done with this practice problem. Let's start with our actual window function in consideration for today, which is also present on the thumbnail. That is row number. Now, exactly, SQL is very convenient and it has not spent its time trying to make the developer or whoever is dealing with it, the SQL user, to spend their time trying to guess what that function is actually doing. They have made it very convenient for you to guess what this function might do. Now it says row number. It will do exactly what it says it does. So it will give a number to each row, correct? It starts with 1 and the numbers would be given according to the order in which they occur. Now what is the order? That will be specified by you, the person who is writing the query. It will generally be specified as order by some column value, and however it occurs, it will be given a row number per value of that. So now you see, while ordering, even though we are considering all of the values together to create an order in which they should occur, but we are giving the row number to individual rows. So the function is getting performed for a single row by many rows. Cool. Now again, we have, wherever we have windows, we will have our over. Before that, we have our function, which was sum earlier because we wanted to get the sum. Now it is row number because we want to get the row number. What row number would do is, it has mandatory, you need to give it order by, otherwise how would it give the number? Everything would be the same number to it. So you have to order by something. If you order it by the start time, starting from the earliest time, which it would give 1, then it will go forward as the time progresses and it will keep giving it a number, consecutive number, depending on where it stands based on the order by clause. If you want that ordering and the numbering to be performed on just limited groups, you can again, before order by, give it a parameter like partition by, and it will partition by that column, create certain groups, and then perform your function on that particular group. However, still for that group, the function would be performed on each and individual rows, and each row would be getting a number, and they won't be just a small part in that entire group contributing to a statistic which would at the end be presented to you as an output. No, each row would have its individual identity and each row would be given a number which would again be presented to you as a result. So now here what they are trying to do is, this we discussed, right? And here they partitioned by the start terminals, whatever were the value is for start terminal, say 3100, 5100, 7100. All of those entries were grouped together, and then within each group it was ordered by the start time. So the start time was 0 seconds somewhere, 10 seconds, 30 minutes, 70 minutes. They were ordered according to their start times when the bike started. According to their start time, they were given certain numbers, which you could find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever it is. Okay, since this particular thing did not have a practice problem attached to it, I made sure that we have something. So this is the practice problem which I would be dealing with. Okay, I have added the link in the chat for anyone who wants to practice it side by side with me. This is the question I'd be dealing with, odd and even measurements. It's a question by Google. So let's get started. Oh, by the way, I had my blog open to show you illustratively how aggregate functions differ from window functions. So you see aggregate functions, there are multiple rows, and all these rows are getting aggregated to one particular statistic, which you are outputting as a single row. However, in window functions, you perform certain operations overall, but each row gets an equivalent output. Okay, so this is the difference. And now we can start practicing our problem. What the problem says is that we are given a table which contains measurement values obtained from a sensor over several days. Okay, now you want to get the query to obtain the sum of the odd numbered and the even numbered measurements. Okay, you just have measurement ID, their value and their time. What you want to get is the sum of odd numbered. So sum we can perform based on this measurement value, but how would we perform the numbering? Because we just have the ID, and what it wants is within a day what should be the odd numbered measurement, the measurements which happened the first time, the third time, the fifth time, the seventh time. Those are the odd numbered measurements. And then we'll have the even numbered measurements, the measurements which were taken the second time, fourth time, sixth time, eighth time. You have to segregate them and then perform the sum on them and get an equivalent result. But that is for later. First of all, we need to figure out how within a day we should get what measurement number was a measurement. So this particular measurement, what number was it? So we'll select everything from measurement. Let's get the measurement ID. Okay, its value. What is the value? And the time which it at which it was taken. And now the fun part. Now we'll try to figure out what number that measurement was taken on. So what was the number of that measurement? So we will use our row number. Okay, row number is our function. We have to take it over a window because we have to consider all of the measurements in that particular day to determine what number each measurement was taken at. So we'll say row number, perform our window at over, using over, and then since we want it per day, we know that we need to divide it into certain groups. And what is that group? That is the measurement date. Here we have them combined. In case you have not check out the previous iteration of the series, the last video which was aired yesterday. It discusses how dates and timestamps are dealt with in SQL and how you can differentiate them, perform certain operations on them. Here I want to get just the date out of this, so I can do it simply by using, say, measurement time and cast it to date. This double colon is used to cast columns from their existent data type to a new data type. Now when I said date, what it will do is it will drop these off and only consider the date part. How this will help is, now we will get our results per date, correct? Within that date, how the measurements were numbered is what we are trying to find. So we've done the job of creating subgroups. Now in order to get the number of each measurement, the chronological number, we need to order it by something, right? What will we be ordering it by? Logically, whenever I say I had 5 students coming in and this was the first student to come, this was the second student to come here. How did I determine that? That happened because of the chronological order in which they walked in. So obviously the walking in or logging in time of the first student was earliest, and then everyone who logged in after him was progressively after him, correct? So if I order by their logging in time, I would be able to see, okay, this was the earliest, this was the last. So I'm ordering it by descending the measurement time. Why? Because the time contains whatever your measurement, when that measurement was taken, that time is recorded here. So when we order it by, obviously 9 a.m. will come first before 5 p.m. We'll be able to get an order of when those measurements were taken, so we can number them, correct? So you see, now within this day, which is 10th of July, you had 3 measurements. The first one was at 9 a.m., the second one was at 11 a.m., and the third one was at 2:30 p.m. So now you see they are ordered, the row number which is generated for that day, for that particular day, is in the chronological order of their measurement time, right? 1, 2, 3. Now for the day 11th of July, the first measurement was taken at 1:15 p.m., the second was taken at 3 p.m., third was taken at 4:45 p.m. and the fourth one was taken at 6 p.m. So now it is arranged in the chronological order of which the measurements were taken. For that particular date, in a day, the first measurement was at this time, then after it the second measurement occurred and it was at this time, then the third measurement, and so on and so forth. Similarly, you would find that once you did the partition by, it just divided your range into different groups. Within that groups, you took a window of certain values ordered by your measurement time, and then from that window you were able to figure out how the row or that measurement is numbered, and you gave it a number. So now we know that the odd numbered rows are 1, 3, and the even rows are 2, 4. Now the next step would be segregating them on the basis of these row numbers which are given to them, and then we'll just simply perform their sum. How will we do that? If you want to know it, let's find out. From now, this will become a subquery because I am performing some operation to extract this. I will give my column analyze. I'll say measure num. So what was that measurement number? Okay. Now this becomes the data source which I am extracting my data from. Now what do I want in order to run this is, I want to get the measurement day. Okay. So the measurement day again would be the measurement time casted as the date. And then what I want is the odd number sum and the even number sum. Okay. How will we get that? The second we say odd number, even number, we know that we'd have to perform some condition to find out if the row number is odd or not. What we'll do is, we'll see there's a particular very peculiar difference between odd values and even values. That is, the even values are divisible by 2, the odd values are not. So what I'll try to do here is, say if my row number, which is as mes num, if my measurement number is if my measurement number is not divisible by 2, that is, if I take this is the mod operator and this is used to get the remainder. So if the remainder is not 0, that is, it is not divisible by 2, then it is an odd number. So I will consider its measurement value, otherwise I won't consider it. Correct? and I'll end my case, and I'll take the sum of it. Why will I take the sum of it? Because we wanted the sum of all of the odd number measurements for that particular day, and I'll say it as odd sum. Okay. Now I will take this row, this entire row, and use it for my even sum. The difference in even sum would be what? That the row number would be divisible by 2. So this, when we are checking, we would have to check whether the remainder which we are getting when we multiply when we divide our row number, the measurement number, by 2, the remainder should be 0. If that is the case, then you consider the measurement value, otherwise don't, and then include its sum as the even sum. Correct? And then, since we have we need to give made up subquery analyze, so that's what I was trying to do, but the autofill was messing with me. Next, now that we have whatever we want, we'll just group it by our date, because we wanted it per date, and then try to run the query. It has an error, of course, because I did not use a when here. I did this mistake yesterday also, I feel. I don't know why I keep missing my when. And is my value same? Let's find out. It is not. So why is it different? Is I am getting my day itself are different. Why? They are considering some other day and I am considering some other day. Oh, mine are not ordered properly. That's why it is giving that error. See, they want it as 10th July, 11th July, and 12th July, and I am giving it 11th July, 12th July, 10th July. So once I order it by the measurement date, now it will work. Now it will be accepted. I hope it is. Yes, it is. So that's how we use row numbers, implement them for real world situations like these. I hope this session was helpful. If you want to get more of such data related content, you can consider subscribing me on YouTube. See, I'm not used to it. I'm a new YouTuber. That's why I'm not able to say these words. They are new to me. And yeah, thank you for joining me in this session today. Where do I work, Sharath? I work for a startup in the AI domain. We create AI related solutions. And thank you for joining me in this session today. I hope this added some value to your data analysis journey. And consider subscribing me and connecting with me on Twitter so we can get to know each other more. Thanks for joining. Thanks, Mino. Bye.